have a sub and I didn't know I was going to have a sub. Okay. This originally I was going to do last Friday, and then I made those extra notes on, of course I just heard a ding, extra notes on different types of fossils. That was not in my original plan when I was building everything 2 weekends ago. Scholarships. Okay, now I can wait to read that. I need to actually create the review paper for tomorrow. I've already made the Kahoot as review. I've already made the test. The test is 33 questions. You have to be able to read cross cuttings. If you cannot read a cross section and look for unconformities and an actual cross cut, or we call those dikes a lot, fault, same thing. If you don't know how to read them, you're going to have a hard time with the test. And I have a whole bunch of images. Yes, it's through Canvas, but I've learned if I use my snipping tool that Canvas likes those. They don't like when I just yank images off the internet. I guess it thinks that it might not be a valid picture. I don't know all the rules of what Canvas does and does not like. So most of them are the same image. If we find out that one of them likes to drop, then I can put those up on the screen. I can freeze them. And if I use the same images, I don't have to put a whole bunch of them up on the screen. So hopefully Canvas likes my snip tool cutout things, which then uploads them as a JPEG. They seem to like it better. For the opener, we have two major eons. We got the really, really, really old Precambrian, which was bacteria, until the very, very, very end. And it started mutating. And then we have the Phanerozoic, which was everything after that. We are in the Phanerozoic. We're at the very, 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 very end. We're literally like, we're probably going to be put into our own epic eventually. I'm not ready to get into a lot of that. This is just sort of like a snapshot of what we will be doing in the 4th 6 weeks when we go into depth. But they are talking about creating our own epic. Epics are only in the Cenozoic, the one that we're in. All the other periods don't have those. But we talked about different ways that we can date things. Would there be a difference in how you date things in Precambrian versus in the Phanerozoic, which is everything after bacteria? Okay, what would you use? We talked about all different kinds of relative dating, which would be the bulk of this. And then we talked about absolute dating, which only goes back so far in time. So where would you use which specific type? Phanerozoic? Only the most recent. Okay, so honestly, we would, if you were using absolute measures, things like uranium-238, yeah, that'll go way back, because the half-life of uranium-238 is 4.5 billion years. Some absolute measure, they can't measure your tissue. They don't measure what you think of as organisms. They measure how much is left behind in a rock. So those would be uranium-238, uranium-234, which is a much shorter half-life. Potassium-40, rubidium-87, which has an insane half-life. That could be used for all of it. But when you're talking about the very, very, very tail end of the Phanerozoic, where we are, then you can use things like carbon-14. And there's tree rings, which were some of the last things that we talked about on Friday. I'm pretty sure I opened everything up in Canvas. I don't think I made any boo-boos. You should be able to see everything for today. There are paper notes up here. Everything else is in Canvas. I don't think I put a lot of images on this one. This one does not have extra pictures. It does not. So we have to map geological time of this planet. We use a combination of relative dating, so superposition and horizontality. This is the stuff that we started with. The sediment lays down, Earth's gravity pulls it down to the surface, whether it's on land or in the water, I don't care, pulls it down, it settles. Eventually it turns to rock, which we call lithification. Once it's rock, then you can have these things that happen from the inside of the Earth trying to come up to the surface. Those are cross-cuttings, faults, dikes, igneous intrusions. There's a couple other phrases that we can put there, fault, but not earthquake fault. This is the stuff that's probably going to get you on the test. We have index fossils. I'm trying to get this stuff ordered. We have some fossils back there, but there's no key. I've been looking online to try to find extra index fossils that are actually labeled properly, and I can use those as reference to figure out the ones that we have back in that cabinet. There are a few of them that I do know. I know the trilobite. I know the clam. There's one more on here. I think there's one more on this. Nope, there's not. Okay, so these were relative dating types, and yes, there are a couple more. And it sounds like I had a ding on one. Let me check that really fast. Actually, I can go to the next one. Go forward. Absolute dating, this is the one that gives us actual numerical values. And it is a combination of the relative, which was just this thing came before that thing. There's no years. And then once we understood electricity and we could get into radioactivity with these mass spectrometers. Yeah, I thought I heard something, but I don't see them. I don't see anybody new online. Oh. How do you, screenshots on Canvas is the window button, and then what I'm looking at on my computer is, I think it's F8, but I don't know what it is. How do let me look at some of these Chromebooks. I want to say screenshot is the control and then the multi-screen button, so above the number 6. It's the button above the number 6, the multi-screen one, control, and then that. Yeah, everything is different with Chromebooks versus computers. Although I am recording this, and I will upload this into Canvas because I just found out that I had a substitute for the back half of the day, and we were told that they took those away from us. So I don't know, maybe they'll take it away again. I don't know. I did not plan for a substitute for the back half of the day. But our absolute ones, going back to about 14,000 years, we use tree rings. Carbon-14 goes about 70,000 years back. There's just not enough carbon-14 left over after so many half-lives to be able to measure it, and I keep hearing dings. So yes, control and then the multi-windows button, which on my computer is F8, but for you guys, it's above the number 6. And then we have our super heavy elements, which are much longer half-lives. Some of them much older than the planet itself. So obviously rocks that were from here that we created by our Earth, uranium-238 is the one that we're going to use because there are no rocks that are older than that very first crust. Just aren't. But meteorites do go older than that, which would be your thoriums, your potassiums, and then I honestly don't even know what we use rubidium-87 for. Its half-life is almost 50 billion years. All right, Precambrian. This is 90% of life on this planet. Okay, this is primarily bacteria. And we started with archaebacteria. There are very few fossils from back in this time. Primarily because things didn't have hard parts yet. The hard parts are what creates the indention in the sediment. Then we come back and just like the whole Bigfoot footprint, we pour stuff into that indention and we create a negative, we create a cast, which is the most common type of fossils. So about 3.5 billion years ago was our first bacteria. About 2.5 billion years ago was you started getting, well, it was a little bit before that. We started creating photosynthesis. No plants yet. Plants did not show up until much further in time. But these cyanobacteria, which mutated and could use the energy from the sun, released oxygen, and it changed the composition of our atmosphere. At the very end of the Precambrian is when we created these things with hard bits, the trilobites. They didn't have skeletons, they had exoskeletons. They had exterior skeletons, not internal bones like we do. Basically like cockroaches. But almost everything was aquatic at this point. And most of our index fossils are marine, not all. I really need to change my notifications to switch between mail and Google Meet. Okay. Why am I getting a message for here? Let me respond to this person real quick. Switched. Had somebody switch classes, and they're still asking me to send this individual work to ISS, and I am not the teacher anymore. I don't think that they knew that. Like I said, everything is just chaotic and moving around, and people going remote and staying here and switching classes and just chaos. But this ability to switch carbon dioxide to oxygen helped push, well, then actually it was the nitrogen before then, helped push the carbon dioxide down into the oceans. The creation of this oxygen pulled the ammonia out, created ozone, which ended up settling up in the stratosphere, and we know that that's what helps protect us from ultraviolet radiation. It doesn't block all of it, but it does block all of the UVC, 95% of the UVB, doesn't block any of the UVA. That's what causes sunburn. Right, so Precambrian has got a couple of different breaks. The Hadean, right at the very end of it, was the birth of bacteria. The stuff that liked the toxic soup that would kill us. It liked the methane, it liked the ammonia, it liked the sulfur. That's what it fed off of. It didn't feed off of light. So the huge section of old bacteria, the archaebacteria, was in the archeon. And then at the very, very, very end of the Precambrian was when we started having multi-cell critters, your protists, things like amoebas, parameciums, euglenas, the things that were more advanced. They didn't have bones, they didn't have brains, they did have nuclei, so did bacteria. But it wasn't encased, don't worry, we're not going to go back to biology. It wasn't encased in a membrane the way it was in a protist. And when we get into evolution in the 4-6 weeks, I'll go more into depth with it. But the switch from bacteria to protists, one bacteria enslaved another bacteria and said, you are going to make energy for me and I am going to protect you. And that was the difference between having and not having mitochondria. You should have learned about mitochondria. It's the powerhouse of the cell. If anything, you should remember that from biology. It was literally an enslaved bacteria. Our mitochondrial DNA is not the same as the rest of our DNA. It's older. Paleozoic, this is where our trilobites started, which is what this little critter is right here. Sort of has like a hammerhead face. We took a look at those. Trilobites are the oldest known fossils. They go back just over 500 million years. And like I said, the ones that we looked at were copies of originals. Cast in mold is the most common type of fossil. At the beginning part, everything was still aquatic, but we started moving off onto land. So we will come back and do these in depth when we do evolution in the 4-6 weeks. Once your plates, and we'll get into plate tectonics probably after Thanksgiving. I'm going to do the 3 major types of rocks in the rock cycle after this test, and that gives me enough time over Thanksgiving break to throw together 3 weeks of plate tectonics. But our plates move over the asthenosphere. And eventually they all came together into one giant mass called Pangea, and that was that first major extinction, which wiped out the trilobites. They were only alive for a certain period of time, which is why they are such a good index fossil, besides they were the first one. And yes, there's different types of trilobites. The largest one is like 70 centimeters. I've seen it past a mold, about give or take about yay tall, so about waist height up off the ground. So the very first part of this is where your bugs, not the flying ones, not the dragonflies yet, they came a little bit later. Your marine hard-shelled critters, for lack of a better phrase to call them. Invertebrates do not have a backbone. They have an exoskeleton. Their bones are on their outside, just like a scorpion or a crab. Or shrimp. I said, we are not going into depth with this yet. Each one of these sections can be their own particular lesson. Oh, at the very end part, that was when the plants started moving on to land. So first, we had fungus, which, like I said, we'll get, this part won't be on the test. We had fungus that came out first onto land. And then we started having early plants, things like mosses and liverworts. Those are your most primal of your plants. And then they started evolving as time went on. We started getting vascular tissue. We had the early conifers, things like pine trees, but not pine trees yet. Things like ginkgos. Ginkgos came first. And then we had our true conifers, which you think of as a pine tree. And then eventually, at the very, very end of this flourish of life, this plant life, we had flowering plants. They were the angiosperms. Those were at the very, very, very end. And I do not know how well your biology teachers went into any of this stuff. Besides, that was only, what, 2 years ago? 3 years ago? For most of you, I think this is your last science class. The paleo, I think it is at least. You guys have to do one more science after this? You have to have so many depending on your endorsement.
Only chemistry and,
Don't you have to have 4?
no.
You have to have 3. I don't know. It used to just be there was like minimum recommended and then like whatever the advanced version was, like the college path version, and that's not true anymore. Like there's like 40 some odd different ways to graduate at this point. It all has to do with endorsements. The split up of the Paleozoic. The Cambrian was, remember pre-Cambrian was mostly bacteria. It was before, and right when we were starting to create things that were more advanced. But your Cambrian, chordate backbone, okay, it specifically started with fish. Your Ordovician, this is where the trilobites flourish like crazy. Your big burst of these exoskeleton invertebrates. Silurian, the very beginning of your plants. Like I said, things like mosses. We're not going in depth yet. Your early fish. We actually have living fossils. We have the coelacanth. That's a lobed fish. We used to think they were extinct until a fisherman pulled one up in a net. And now it's in an aquarium, and I've seen it. Their fins, seriously, look like, almost like arms. And then the fin is on the outside. Like it very much looks like a leg, it just doesn't have toes. Devonian is your big explosion of plant life. Ferns. In fact, one of the most common fossilized plant that you're going to see in these carbon imprints, which is like a negative, will be a fern. And you can see, please tell me I froze that. You can see the vasculature in them. And like I said, I need to order separate index fossils that have a lot of those because the ones back there, it's not the best set. I don't see anybody else talking on there. Your Carboniferous, this is your big flying insect section. Dragonflies that were as large as we are. Somebody asked if they could pick you up and fly you around. No, we're too dense. cockroaches. What you think of modern flying insects. And then the Permian, this is when those ammonites, those spiral looking shells that have been around for so long, and is an absolutely wonderful index fossil. That was at the tail end of the Paleozoic. Modern pine trees, herbivores, things that eat plants, because now we have decent plants for them to eat. Things were mostly not herbivore, not omnivore, carnivores. These were mostly carnivores before then. The Mesozoic, this is the one that you think of. This is the dinosaur section. And this is the age of reptiles. This is where you had your very, very early dinosaurs and your pre-dinosaurs. They started theropods, 4 legs on land. They started almost in a swampy type habitat, and then they moved into primarily just being on land. They went from 4 legs to 2 legs. This is where hard shells developed. I mean, technically humans have eggs too, but everything's inside. You don't like lay an egg and incubate it the way birds and reptiles do, but that particular adaptation did occur in the Mesozoic. And the dinosaurs, before in the Permian, these were your pre-dinosaurs. Like I said, we'll go into depth with this in the 4 to 6 weeks when we do evolution. But your pre-dinosaurs were essentially swamp livers. Swamp livers. Yes, not like a liver, like they lived in more of an aquatic environment to help support their weight. And then they moved on to the land in the Triassic. The Jurassic is the one that you think of with T-Rex. They were not all alive at the same time. And then we went into the Cretaceous, and that was at the tail end when the asteroid slammed into the Yucatan Peninsula and wiped out these giant dinosaurs and allowed mammals to flourish. Mammals actually developed in the early Triassic, right along with the dinosaurs, but they were teeny tiny little rodent living things. That is what we evolved from. Almost looked like a possum. I keep hearing dings and I don't know. I probably should take attendance. That would be smart. And fix my seating chart. Movies, Fragrance, remotes, buildings, money, Alex, Cameron, Kale, Caden, Erica is not here. Pete Decker and Colton are online. I don't see Courtney. I don't see Caitlin. I don't see Joseph. I don't see Valerie. I'll double check online if I just said your name. Don't log off yet. Come back on and double check you and get yours. There it is. All right, moving a little bit more modern. Like I said, mammals did actually appeared before birds, but the mammals that appeared in the Triassic were these very, very small rodent-like creatures. Honestly, with the asteroid that took everything out, it was the big things that got out. They just couldn't support themselves. There wasn't enough plant life to be able to support their metabolisms. They were too large. Your smaller critters did survive. The last of the dinosaurs, except with a few exceptions, basically the alligator and the crocodile, those survived. That particular, they're smaller than they used to be, but that particular structure of organism has been around for a very, very, very long time. Most of the dinosaurs that made it through, though, they changed. They changed to birds. It started in the Jurassic. And then we have things like Archaeopteryx, not the pteranodons and pterodactyl, like what's in the picture. These feathered, gliding reptilian bird hybrids was the beginning of what ended up being the sparrow and the chicken and all the other birds, the ostrich, all the other birds that we have. Some birds are much more dinosaur-like. They've retained a lot of the same qualities. They have scales. That's what a feather is a modified scale. I mean, I don't know if any of you have seen a live chicken. But when you pick them up and you look at their legs, you can see the scales. In fact, the bottom of their feet is very, very, very soft, very pliable.
Oh, yeah.
Yes, if you ever have chickens, you have to pay attention to their feet, because if they get a thorn, if they get an infection, it doesn't turn into a pimple like it does for us. You have to literally flip them upside down, put them to sleep, and cut them out. It'll kill them. It's called bumblefoot. Whoa, that's not fun.
You can be like one chicken battle, all of them can battle. Yeah.
It's essentially a pimple. Because they're scales, it's not like popping a pimple when you get the pus out. You literally have to, you have chickens, you know what I'm talking about? You flip them upside down and it puts them to sleep.
Yeah.
And then you literally take a scalpel, you wrap them up in a towel, like a baby. You take a scalpel and literally cut around it and pop it out. And they're literally asleep on their back. Chickens are so weird. They'll do that too. And I've been told you can do the same similar thing with alligators, where putting your fingers right underneath the jaw, and I am not trying this in real life. I'm not trying this in real life, but I've seen like the crocodile dude that got stabbed in the heart with by the stingray. He's literally just put pressure right underneath the bottom of the jaw where it's soft, and you lift them and they go to sleep. Like I said, I'm not trying that in real life. I'm sorry, I'm not sticking my hand anywhere near an alligator or a crocodile. I've also heard you can draw a line in the dirt in front of the chicken's face, lay it down and draw, and they won't move. It like hypnotizes them. Strange critters. So, 3 major parts of the dinosaur era. The Triassic is your early part. Ichthyosaur are the fish dinosaurs. The Jurassic is the part that you think of. And the Cretaceous, yes, there's still dinosaurs here. Triceratops was in here. The Brontosaurus was mostly Jurassic, but started into the very early Cretaceous. This is where we had what are called angiosperms, or flowering plants. Yes, there were other plants, things like ferns, things that have seeds. They don't create flowers that need to be pollinated. That was a very, very, very late development. Right before the asteroid came in and wiped out a bunch of stuff. And I've got a couple of them in the era that we're in right now. Which, yes, that asteroid wiped out a bunch of stuff, but it allowed the mammals to flourish in the next era. If it wouldn't have happened, your reptilians may still be your dominant species. Because that happened, those little mammals that didn't need as much food, didn't need as much cover, they flourished. We're getting into where we are in the Cenozoic. So we will come back and do this much more in depth. I need to brush up on the dinosaurs. So from that asteroid impact on, about 65 million years ago, we had what's called the Cenozoic. The Cenozoic is the only area, or the only era that has epochs. None of the other ones have an epoch. It's just the most recent. We had a massive temperature reductions, and why? Was because of the asteroid strike. So asteroid hits the ground, puts up massive amounts of dust into the upper stratosphere, which cannot be rained out because there's no rain up there. Blocks out the sun, reduces the temperature. We have an ice age, like a really long ice age. And the reptiles, which we don't know for sure. We're pretty sure they were cold-blooded, but it's not like we can go back in time and check them out. But if that is true that they were cold-blooded, then that would make sense as to why that asteroid strike obviously wiped out some just from the sheer impact. They were too close. Then the reduction of light, photosynthesis, wiped out a good portion of your herbivores. Not enough herbivores running around being able to create meat for the carnivores got down, but that lower temperature, they just couldn't compensate. which is what allowed mammals to flourish. Warm-blooded, and they come with their own fur coat. It's still stuck on my glasses. Your primates evolved here. I know when I taught at Beaumont, they always got, we didn't come from monkeys. No, we didn't come from monkeys. We shared common ancestors where the great apes went one route, and then your smaller primates, like the capuchins, the little itty bitty ones that people have as pets, because why you would want a monkey, I don't know. Your lesser apes had a different route, and then our pathway was a different route. And some of them survived and turned into modern day people, and others did not. What Homo sapiens translates to is wise man. Is actually what that translates to. And we've got a couple different parts of the Cenozoic. I think there's one more on here. Oh, yeah. The oldest, the Paleogene, and this is where the horse started with this, which was the size, seriously, of a decent sized dog. They were very, very, very small. They had toes, they didn't have hooves back then. The rhino and the elephant are older. They've been around, their style, their body style has been around a lot longer than ours has. Primates started in the Neogene, that's where our lineage started. And then the most recent one, the Quaternary, this is what you think of with the movie Ice Age, mammoths, the giant sloths, the cave bears, woolly rhinos, saber-toothed tigers. That's where all of them started from. And yes, early people were around back then too. And like I said, they are talking about creating a new epoch for people, like how much we've changed in such a short period of time that we are nowhere near the same as the Cro-Magnon and the Neanderthals. Could they survive in our time period? Yes. Could we survive in their time period? Nowhere near as easily. We're different because of all this technology, all the inventions that we've done. We're completely and totally dependent on them. Now, I still need to create the review for you guys. I've created the test. I've created the Kahoot. I just haven't created the paper version of it. I'll be doing that today. We are going to review tomorrow. The test is Wednesday. We will do the rock cycle on Thursday. I've gotten through that. I don't think I made the assignment for it, but I've gotten through the notes on there. And then I believe we will do igneous rocks, specifically Friday, metamorphic rocks, specifically Monday, and then sedimentary rocks, specifically Tuesday. We'll review. We'll have another test Thursday, and then I'll have a makeup day, make sure everybody's taken care of on Friday, and it is Thanksgiving break. I don't have enough time to get into starting plate tectonics. I just don't. So we will start those up about the mid-Atlantic ridge and rifts and the way that the crust is more dense in certain areas than the other when we come back from Thanksgiving break. Now let me check online. Let me stop the thing so that I can post it. Because I currently have a substitute. And it's going to be substitute.